Don't believe it. Two things. First, Al Gore has expanded this piece of the graph, and it should go zip almost straight up on that scale. Secondly, any biota that has that kind of behavior is a plague response, and it doesn't stabilize at the peak. It mines resources, it strips resources, and we have also found financial instruments, which means we can mortgage the future to drive today as well. So we're exporting debt into the future, we're bringing resources out of the past, and we're destroying the capital assets of the present in order to get this enormous sense of a bubble that is heading for burst. So in normal circumstances, you would expect this to come almost to a peak and then go into a massive collapse behavior. And I do not believe the people talking about population when they say it's going to stabilize about halfway through the century or towards the 18th century, and then we will go on trying to feed a population. So we have enormous troubles ahead on the population issue, and that itself is a root of enormous violence in the system. Think what it would be like to live through the forced deconstruction of a mass population of this kind, what that would imply. Now, I spoke about the use of energy, and of course one of the things that happens with our use of energy is that we actually push out pollutants as well. So pollution and energy use per capita have raced up through this period. The energy use would have gone way up on that because per capita use of energy has been rising as well. It's not just population times energy use equals pollution. And it's not what you see, it's what you don't see. It's the carbon dioxide that comes out of those chimneys and out of every other internal combustion that then becomes externalized pollution. And we know this. This is all old hat for most of us, isn't it? And the height that we have made here, which is now up to 387 parts per million of carbon dioxide this year, at this moment, is a jump that is at least equivalent to the difference between the glacial and the interglacial period. If you add on other gases, we're at about 450, 448 parts per million of carbon dioxide equivalents, and accelerating dramatically. So we have done violence to the contained climate behavior of hundreds of thousands of years. Right, fast forward. Here we go. Increasing those carbon dioxides and greenhouse gases, of course, increases the efficiency of the envelope. Watch the red arrows. Energy in should balance energy out. What we do is we reduce the outgoing and heat up the surface. Now, suppose we cap concentrations at 440, 450, 500, whatever it is, and it stabilizes. Then the theory is that radiation recovers and establishes a new equilibrium between incoming and outgoing energy at a new stable temperature. Basic understanding of classical climate change underlying all our current negotiations. Just come back from the European Parliament from the big meeting trying to drive through this 450, 440 cap and a 2 degrees safe ceiling. Doesn't work. Okay. Two reasons. One, we're accelerating the accumulation of greenhouse gases faster and faster and faster. No slowdown with Kyoto as yet. But far more importantly, not only are we reducing the outgoing energy more and more powerfully, so what we call radiative force of global heating is increasing and increasing and increasing, but the feedbacks of the system are pushing it ever further out of balance and increasing the heat engine that makes the climate go faster, which makes the temperature go up more, which makes the feedbacks go more, which drives it further and further. So we're now in a situation of feedback-driven climate change, which was not expected and is not properly modelled. Let's look at that in slightly more detail. We see that the feedbacks drive us ever more out of balance, and move us possibly to a hot Earth scenario, which is a major extinction event rather than just a 2 or 3 degree shift and difficulties of coping with what we call catastrophic climate change impacts. There is a threat to the system as a whole, which is of a different order from what we had been expecting in climate change. Let's build some understanding of what that looks like. I could use probably, this is where I sit down for a moment. This is all laid out in much greater detail in the book, so please go to that and refer to that for the background. Concentrations of carbon dioxide go up and increase the heat engine. So does methane. Other greenhouse gases do the same. The reflection from ice and so on changes the heat engine. Aircraft trails, dust particles, and black carbon also affect that. Cloud effects and water vapor concentration is a feedback. There's a lot of water vapor. It's a powerful greenhouse gas. Once you stop the temperature rising, you increase the density of water vapor, and that drives the greenhouse effect much more strongly. By the time you've got up a change of 1.5 degrees Celsius, water vapor feedback is giving us the same driver of climate change as everything we've done from carbon dioxide. Ouch. Now, what we've done in that, by the way, geothermal energy is very small, so we ignore that. Solar energy, of course, is the main drive of everything. We have now pushed the system so that we are holding back about 1% of received solar energy to heat the Earth. That's way away from equilibrium, because it's been about 1/100th of that, even in the most rapid climate change in the past. Now, these are the clusters of feedback groups and feedback processes. How am I doing on time? About another 15? Oh, that's incredible. Doesn't time fly when you're having fun? These are the feedback clusters. I'm ignoring that one because it's small. This is the main damping or negative feedback. Remember, in this game, positive feedbacks are the bad guys, negative feedbacks are the good guys. Negatives damp us, positives accelerate it. So I talk about accelerating feedbacks and damping feedbacks. The hotter the Earth gets, the more it pushes out infrared radiation. So that decays the heat engine, that lessens the amount that is being used to put the temperature up more. So the hotter it gets, the slower it gets hotter. And that's the biggest damper on the system. The idea being, we have a limited amount of CO2 in the atmosphere, temperature plays catch up until it pushes the same amount of heat back out again as it did to start with. That's where that feedback comes in. That's the only controlling feedback that has real significance in the system. Now, F1, surprisingly, Formula 1, is driven by carbon dioxide concentrations and increases the rate of accumulation in the atmosphere. The main mechanism is that increased CO2 concentration damages the sinks, so we don't take out of the atmosphere as much as we did before, so we accumulate more. All the other clusters, 2, 3, 4, 5, and 6, are driven by temperature itself. A bit like this. So we have F1 is both driven by and acts on the carbon dioxide. All the others are driven by temperature. And these clusters of feedback processes then act on the different drivers of climate change like that. So the structure as a whole says as temperature rises, the effects come into feedback processes that increase the heating, that drives the temperature, which in turn goes through the feedback processes, drives the drivers more powerfully, which increases the heating, which increases the temperature, and you've got this, okay, body language stuff on here, verbal, book, DVD, you've got a multimedia presentation in one moment.